Life is good. Okay, so first of all, let's take a look at this square. Everybody agrees the area is 1. Thumbs up. 1 by 1, the area is 1, right? So if I were to take this square and cut it in half, right? So the area is 1/2, and then cut that in half, right? And then cut that in half, right? And then cut that in half. I just want you to watch, right? And then cut that in half. And cut that in half. And then cut that in half, and cut that in half, and cut that in half, and cut that in half. Well, the question is I can cut this thing in half forever. You guys agree with that? I mean, but I know that if I did cut it in half, I went dot, 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 dot here, that I knew that the area, the answer would have to be 1. You guys agree with that? It's got to be 1. But you have to get to infinity for it to be 1, which is kind of impossible. Well, it is impossible. But in theory, we can say if we got to infinity, the area is 1. And not only that, but then you get these little pieces here which mean nothing. You got like molecules and then atoms. So let's just say that if we took the area of this thing, it's got to be 1, okay? So then we want to graph the partial sums. Okay, so the partial sums are like this. Let's see, I want to go 1, 2, 3, 4, 5, 6, 7, 8. I can go 8. So that means 1, 2, 3, 4. That would be 1/2, right? 1, 2, 3, 4, 1/2, 7, 8, and so forth. Okay, or we can even use decimals. Might be easier. But so my first partial sum is 1/2. So partial sum is 1/2. So I'll put a dot there, 1/2, right? So here's my first. It's 1/2. That's first partial sum. And then if I add 1/2 plus 1/4, I mean I can do it on a calculator if I want to, but hopefully I know that if I've got my first sum is going to be 1/2. Sum 2 is going to be 1/2 plus 1/4, and that's 3/4. You guys agree with that? 3/4. That's 7/8 there. That's 3/4. Come on, Bill. I know it's Monday. So 3/4, and then sum 3 is going to be 1/2 plus 1/4 plus, what's the next one? It's going to be my 1/8. That's 7/8, right? 7/8. And then my next sum is sum 4, which is 1/2, plus 1/4 plus 1/8 plus 1/16 is 15/16, which is here. And then if I take a look at what's going on my graph, the next one's technically going to be here, here, and here, and here. And so if this is the area of 1, I keep getting closer and closer to the area of 1. It just proves another way that if I keep going, you get closer and closer and closer to 1. Okay, that's a graph of the partial sums, okay? So how about the infinite cut? Well, we know the infinite cut, that the sum to infinity, okay, put that down. The sum to infinity is 1. But you have to get to infinity to get there. I would agree with that. So what we want to do is talk about the sum to infinity. But the biggest thing that we need to know is this. My pieces have to keep getting smaller and smaller and smaller and smaller and smaller, because if my pieces got bigger and bigger and bigger, then the sum would be infinity. Okay, if my pieces get bigger and bigger and bigger and bigger, this thing gets huge, it goes to infinity. Okay, so now let's take a look at what I have on the notes, now that you guys got kind of an idea what I'm talking about. Okay, so our objective is our sums to infinity, right? And normally you would have thought, well, gosh, Mr. Davis, you add to infinity, the answer's got to be infinity. But we found out, nope, not true, right? Sometimes when you add to infinity, you can go to a sum, okay? So infinite geometric sequences, okay? So if an infinite geometric sequence is a listed number, so for example, if I had, my 1/2, comma, 1/4, comma, 1/8, comma, 1/16, comma, 1/32, write that down. Now if I got dot, 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 that's going to infinity, right? if I did 2, 4, 8, 16, 32, dot, 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 okay? This one eventually will go to 0, and this one here is going to go to infinity. So we know this one's approaching, actually, 0, because it's getting smaller and smaller and smaller. Everybody see that? You guys agree? This is getting smaller and smaller and smaller and smaller and smaller. So if you could get to infinity, if we can go dot, 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 we're approaching 0. But this one's getting bigger and bigger and bigger. This was actually approaching infinity, okay? Now, this word divergent and convergent, all right? Divergent and convergent. Converge, it's going to converge, which means it's going to go somewhere. So convergent means, the word convergent means it's going to go to a number, to a value. Convergent, so convergent will approach a number, approach a value, approach a value. This one, the first one, is convergent because it's going to 0. Divergent means it's just going, divergent means it's going to infinity or negative infinity, okay? So if it's divergent, it's going to approach either infinity or it could even approach negative infinity, but it's just going off the chart, right? So this one is divergent. So the first couple examples are kind of easy, right? Example 1, we kind of did example 1. So we take a look at example, because 1, 2, 4, 8, 32, and that's basically what we did here. It's getting bigger and bigger and bigger and bigger. This one's heading to infinity, so we'll say it is divergent. Okay, so far seemed pretty easy, right? I mean, if it just goes off to infinity or negative infinity. How about number 2, 0.9, 0.99, 0.9999, 0.9999999? Yeah, Ellie? Nice. Yes, it is convergent. And it is approaching positive 1. Good job. That's exactly right. It is approaching 1, right? In fact, in theory, and not in theory, but in math, 0.9 repeating is 1. Well, it is. 0.9 repeating is 1. Now, 3 is a little bit tricky, so use your mind. Use your mind, okay? What do you think? What's going on with the third example? Okay, what happens? Okay, so then what's the next number? What's the next number? 50, 30, yeah, 10. Okay, then what's the next number? And then what's the next number? Oh, then what's the next number? Yeah, so at first you think, oh gosh, it's going to 0, right? But no, it hits 0, it keeps going, right? So what do we know? Is this one convergent or divergent? This one's definitely divergent because it's heading to negative infinity, right? It's going to keep going dot, 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 dot to, and eventually it's going to approach negative infinity. So this one's divergent. Okay, now example 2 says to find the sum 10 plus 1 plus 0.1 plus 1 point, so it's like 11, 11.1, 11.11, right? So it seems like to go to infinity, the pieces get smaller and smaller and smaller, so it seems as if it is going to something. So we need a formula. And so we have this S of infinity formula, okay? I'm going to write this down. And it is A1 over 1 minus R. Okay, write that down. That's our formula. So we got one more formula, S infinity. But it only works if it's convergent. This formula only works works if convergent. So if R, which is our multiplier, if R is between -1 and 1, this formula can be used. And what do I mean by that? If R is less than 1, it's in between -1 and 1, okay? And I'll shift up here. R in this case was 1/2. I multiplied by 1/2. I multiplied by 1/2. I multiplied by 1/2. I multiplied by 1/2. See that? And when I multiply by a decimal or a fraction, something less than 1, it makes it smaller, doesn't it? So if your multiplier is less than 1, but here my multiplier was 2. Multiply by 2, multiply by 2, multiply by 2. So if R is between -1 and 1, then it's going to end up getting smaller, smaller, smaller. So in our case, in this case, our R, this R happens to equal 0.1, right? I multiply 1/10 or by 1/10. 0.1 is the multiplier. In fact, I'll show you. If I take 10 and multiply by 0.1, I get 1. If I multiply that by 0.1, I get 0.1. Multiply that by 0.1, I get 0.01, right? So our multiplier is 0.1, so I can, so if it is, I can use this formula. So let's use this formula, okay? So I'm going to go S of infinity is going to equal A1, that's my first term, which is 10, divided by 1 minus the multiplier. And the multiplier, the R, is 0.01, so 1 minus 0.1. I'm just going to use my calculator. What is 10 divided by, parentheses, 1 minus 0.1, and I get an answer of 11.11111 repeating, or 11.1 repeating, or 11 and 1/9. So it's going to be 11.1, and you can do the repeating. It is 1/9, okay? Now, every repeating decimal can be changed into a fraction. We got 0.45. So in a sense, it says find the reduced fraction that's equivalent to 0.45. Okay, so let me show you what's going on. I have 0.45 plus, okay? So this problem is 0.45454545, right? It's a repeating decimal. So it would be 0.45 plus 0.0045, right? That puts me there. Plus 0.000045, right? Plus, that put me there. Plus 0. Okay, that is really what's going on. If you were to add all of these, they kind of fit in with the 4 5s. You see that? If I add these, that 4 5 fits there. If I add these, that 4 these, they fit there, okay? So it should be some fraction. So let's use our formula. We've got this S of infinity problem, because this goes on forever, right? You guys agree? It's a repeating decimal, it's got the bar on it, so it's going to go forever. So let's use our formula. S of infinity is equal to A1, which is our first term, which is our 0.45 over 1 minus. What's our multiplier? Anybody know what our multiplier is? What's our multiplier? How do I get from here to here? What's our multiplier? What's our R? What's our ratio? If you're unsure what your ratio is, you can always divide the second one by the first one. You can always divide the second one by the first one to find out what your multiplier is. So if you go 0.1245 and divide it by, you get 0.1. Yeah, I'm pretty sure. So that's my multiplier. So R in this case is 0.01. Okay. All right, my goal. Okay, to go back, what I want to do, I want to find a fraction, a reduced fraction. Okay. So if I make this 0.45 over 0.99, right? Because 1 minus 0.01 is 0.99. And then if I move both decimals over, I've got 45/99. Really is. If I reduce both, can I reduce? Yeah, by 9, right? I'm going to do 45 by 9. I get 5 11ths, don't I? Well, let's check it out. On 5 divided by 11. Ooh, there it is. 5 11ths is 0.454545454545. It is. It worked, okay? All right, let's turn the page, see what I got on the back, okay? All right. Number 3, find the sum. So I've got a formula. I've got my S of infinity equals A1, 1 minus R, okay? But before I do anything, I got to figure out what R is. So one way to find R is to take the second one divided by the first one, okay? That always works. If you can't figure out what R is, you can always take the second one divided by the first one. So, all right, if I do that, I'm going to go -4 divided by -6, and I get, well, that's 2/3, isn't it? I mean, really, if I go -4 divided by -6, that's 2/3, which is the right R, okay? It's less than 1. So I can use this formula. You cannot use this formula unless R is less than 1, okay? So let's use my formula. S of infinity, if I keep adding these, should be A1, which is -6, over 1 minus R, which is 2/3, okay? I don't really like decimals, you guys. I can do some fractions. I can. I'm good at fractions. -6 divided by, well, that's going to be a 1/3. 1 minus 2/3 is 1/3. You okay with that? 1 subtract 2/3 is 1/3. And then that same thing is a -6 over 1 times, because we're going to fraction, invert, multiply, 3 over 1, which equals -18. So if I kept adding these, well, that's 10. If I keep adding, the pieces get smaller, but all the pieces add up to 18, okay? All right, example 4. All right, sum to infinity. Here's what I know. I mean, I know that we had this geometric. We had A1 R to the n minus 1 power, right? We had that last week. So R is 1/3. I like that, right? That's my little formula from last week. I know R is 1/3, and that's good because it's in between. You know, it's less than 1, so I can use this formula. And I know the first term is 4, right? Everybody agree with that? Fits this perfectly. So here's what I know. I know A1 is 4. I know R is 1/3. And if I were to make a few terms, you'd see that it is getting smaller and smaller. In fact, if I make the first term, it goes 4, then it goes 4/3, then it goes 4/9, then it's going to go 4/27. Trust me, okay? It's just getting smaller and smaller and smaller, right? And then if I were to add them, it should have some sum. Okay, all right. So I'm going to use my formula, my S of infinity formula, A1 over 1 minus R, okay? Well, A1 is 4. So S of infinity is 4 over 1 minus my multiplier, which is 1/3. So I get 4 divided by 2/3, right? Which makes, if I invert multiply, it makes 12 halves. Flip that up, I get 12 halves, which is 6. Okay, last example. So if you're a doctor, and you know, they actually look at charts. So if you get medicine, a couple of things they do is they talk about this half-life. I take medicine. I've taken medicine, Lipitor, for the rest of my life. It's kind of a drag. But what they give me is like 20 milligrams of Lipitor. But if I take it every single day, then it is more than 20. It actually goes up my bloodstream, okay? So this person has to take 400 milligrams, right? But it's got a decay rate of 20% every day. So that means 80% would be left, right? So I'd have my 400 times my 0.8. And so then I'd have 320 of it left in my system. And then if I kept doing that and then take times that by 0.8, and then I'd have 256 left in my system, and so forth and so on, right? So the thing is that this first dose, let me do this again, times 0.8. I want you to see this. 204. Okay. Now, think this through. You got to work this backwards. You got to work this backwards. So this is, in a sense, a new day. I've been taking this for all this time. I took this medicine, but some of this from yesterday is still in my bloodstream, right? Some of this from the day before is still in my bloodstream. Some of this from day before is still in my bloodstream. So all of this medicine, if we add it up, is still in my bloodstream. The question is, how much is still in my bloodstream, right? Well, you call it to infinity because eventually, it's going to go down to nothing. Maybe it takes maybe it takes a month for it to go down to nothing, right? Oh, that's the problem with drugs, you guys. They can test this stuff in your blood, right? And it's still there. So now, this is an infinity problem. S of infinity, A1 over 1 minus R. Whoops, 1 minus R, my bad. So my first dose, which is really the dose I just took, is 400 for 1 minus, my multiply is 0.8. So let's see what it levels off to. So about 2,000 milligrams is what it levels off to. Isn't that crazy? Okay. Homework. Boy, I talked a lot today, didn't I? Sorry, you guys. We got a little time left I can help you with. Page 213. I want you to do 1 to 7, and extra is number 8, okay? All right. Let's take a look at this, because we can probably get this done before the bell rings, huh?